Welcome back to the Bits of Good Bootcamp. In this video, we're going to talk about React state and React component life cycles. Alright, so first let's talk about state. So state is similar to props, but it's private and it's fully controlled by a component. So whereas props is something that is passed into the component, so meaning it comes from the outside, state is all internal to the component. And other components are not able to access the state, it's just inside that one component. And really, state is how you allow React components to change their output over time to respond to users' actions, to network responses, data from the database, like really to anything. State is how a component knows that time has elapsed and that something has happened. It's essentially like saving information inside of a component. The important thing to realize, though, is that state is only available in React class components. So before we saw that there were two ways to create components with functions and classes. State is only available in class components. So just to kind of get a refresher here of how you convert a function component to a class component, we see here that on the left we have a function component, which is our handy dandy clock. And on the right, we have turned it into a class component. So really the only thing we're doing is we're adding class, name of the component, extends React component, and then whatever was returned by the functional component, we make returned by the render function of the component class. Fairly straightforward. So now if we want to add state to a class, we're going to actually add state to the props example that we saw before for the clock. There's three steps. The first thing is we're going to replace this.props.date with this.state.date. So here this is the only change that has occurred. Everything else looks the same. The second thing we need to do is we actually need to add state to the component. And the way that we do that is we use the constructor. So this is another element of the class component that we haven't talked about yet. And inside of the constructor, we are declaring the state. This.state is equal to an object. The state is always an object, or should always be an object. And it has a date attribute, which is current to the new date. And it's important to kind of point out here that whenever we're calling the constructor, it's important to first call super and to pass in props to super. If you think about it intuitively here, super is actually the constructor of the React component. So we need to make sure that we call the constructor of the React component, not just of our implementation here. All right, now let's actually render our clock here. And so we should see that our clock will work. And let's check this example. And we see that, in fact, our clock does work. This is the same code here on the left as we've seen before. But our clock's not actively ticking. In previous examples, the clock is supposed to tick. It's supposed to change every single second. And before we had a set interval call that did that, but I told you that was a pretty hacky way because what we were actually doing is re-rendering the clock every second, which really isn't what we're supposed to do. So let's talk about how we can do things like updating. And the way that we're going to use to do it is something called React Lifecycle methods. So this shouldn't be something that's altogether too new. If you've ever done any kind of app development, whether it be Android, iOS, everything has a life cycle. And so this is the React life cycle. Let's go through it really quick. So at the beginning, we have our mounting phase. And so this is when our constructor is called, and then the render function is called. And then this is when it actually gets put onto the DOM. And so you have this, this lifecycle hook, component did mount. This gets called after a component actually hits the DOM, after it is present on the screen. This is the function that's called. And then our next cycle of the life cycle, we have updating. And so whenever new props are received, whenever setState is called, we'll learn about this later, and whenever force update is called, we're not really going to talk about this, it's going to trigger a re-render, and then that will again change the DOM, and component did update will get called again. And now finally, if for whatever reason our React application decides that it no longer is supposed to be showing a certain component, maybe we've navigated to another page, we'll enter the final stage of the lifecycle, which is unmounting. And this is actually removing that component from the DOM. And when that is completed, it's going to call component will unmount. Now, for our specific example, we want to implement some ticking. So we want ticking to start when a component mounts, and we want it to stop when a component unmounts. So intuitively, you should think, okay, well, the ones that we're going to want to use are component did mount and component will unmount. That's how we're going to hook into the lifecycle to be able to make our clock tick. And this is how we go ahead and do that. So again, our React component is getting a little bit longer here. So pardon the smaller text, but we see here that we have our component did mount, and here we have our timer ID that we're saving, and we're setting an interval that is going to tick every second. And then inside of our tick, all we're doing is we are updating the state to be the new current date, the current date and time. And then finally, when we unmount, we're going to clear interval, and what that's going to do is essentially just stop the ticking, and we'll clear the interval with the timer ID. So that's all it takes as far as how we're able to hook into those lifecycle hooks. But it's also really important to talk about using state correctly. In here we've used state a couple times. We are setting the state here every single time, and then we are also displaying the state, and we're initializing the state. So let's talk about our rules for using state correctly. And there are 3 things to know about using setState. First, it does not modify the state directly. State updates may be asynchronous. And finally, state updates are merged. So let's go into these one at a time. So the first thing, we never modify the state directly. So the first example here, if you try to directly say this.state.comment is equal to hello, this will not update your React application. If you try to do this, you will spend 25 minutes debugging, trying to figure out why your application is not showing what you're expecting it to show, and the reason is because you're directly modifying the state, which is not allowed. The proper way to modify the state is to call this.setState. So you see here that we're calling this.setState. This is the correct way. If you wanted to set comment to hello, you would do this. And then the only place that you're allowed to assign to the state is in the constructor, because that's where you initialize things. So there it's okay. But nowhere else in your code outside of the constructor should you ever call this.state. Second, it's important to realize that state updates might be asynchronous. And so what this means is that React might actually batch multiple setState calls into a single update for performance reasons. So if your application is designed in such a way where you call setState 3 times within the span of 1 second, React is probably going to take those 3 setState calls, merge them together, and only execute it really once. Even though you're trying to call setState 3 individual times, it's only going to call it once. And so this can lead to some issues here if you try to use this.props or this.state inside of your setState call, because it's asynchronous. And so the way that we get around that is, instead of just passing in an object, so here we're passing in an object, we're actually going to pass in a callback function that is going to take the state as the first parameter and the props as the second parameter, and now it is safe to use the state and the props to update the state. And the reason is because when React detects that you're passing it a callback instead of just an object, instead of just merging the state update in, it's actually going to pass you what it has as the current state and what it has as the current props, and then it'll allow you to use those to tell it what the object that it should merge in. So here you see our callback is, at the end of the day, still returning an object. Okay, and then finally, the last thing is that state updates are actually just merged together. So when you call setState, what React is doing is it's merging the object you give it with the current state. So in this example here, we have our constructor, and I've initialized posts and comments as 2 arrays. And now inside of component did mount, I'm going to fire off this asynchronous thing to get posts from my database, and then I'm going to set the state with posts equaling the posts from the database. But the cool thing here is that even though I'm only having the posts element be included inside of the set state, it's not going to ignore, or it's not going to like remove comments. It's just going to basically ignore it. It's not going to do anything. It's just going to do a shallow copy, and it's going to replace the posts here with the posts that I'm giving it in set state. And the same thing occurs here for comments as well. And so here we see on the side, the merging is shallow. So this.setState posts leaves this.state.comments intact, but completely replaces this.state.posts. Alright, and now we're going to talk a little bit about the data flow inside of React's components. And so it's important to realize that components are pretty independent. Parents and children are pretty much ignorant of everything else that's going on around them. They don't know if other components are stateful or stateless. They don't know if other components were implemented via function or via class. And honestly, they don't need to know these things. They're just operating in their own abstracted little corner of the room. And of course, we said before, state is local and it is not accessible to any other component. But sometimes a component might want to pass down some of its state to another component so that the other component can use a piece of the parent component's state to display something. So here, for example, we have this formatted date. So I might have a component above this that wants to display a date formatted by formatted date. And so the way I can do that is passing formatted date a prop that includes my state. So let's break this down here. Date here is the prop from formatted date. This is the prop side of things. And inside of curly brackets, what I'm passing inside is a piece of state of the enclosing component, the parent component. But it's important to realize, like, formatted date doesn't know that it has a piece of somebody else's state. It just knows that it received some value as a date prop. It doesn't know how that value came to it. It just knows that it has it. So let's take a look here just at this CodePen example, just to make sure we have a good reach on what's going on here. So I'm going to pull this up here so we can see a little bit. So here we first have a functional component, formatted date, the same thing we saw before, and it is just printing out the date properly. Then we have our class component with all the ticking already taken care of for us, and we see that I have, as part of my state, this.state.date, which has the current date and time. And what I'm doing is I'm actually, inside of the clock render, I'm passing formatted date, this.state.date, as a prop. So formatted date up here is just going to independently say, okay, well, I'm expecting props and I'm expecting date to be one of the items in props inside of that object, and I'm just going to use that. It doesn't care where any of this came from. And then finally we see that it's just updating on our screen and working as we expected. Okay, so another thing is, in addition to data flowing down, like typically what we call that is like top-down data flow or unidirectional data flow, because data cannot flow up a component chain. Like it can only flow down, kind of like a waterfall. And any state is always owned by a specific component, but it can be passed down via props if there's other components further down that rely on that piece of state. And also, it's important to realize that state is isolated to a specific component. So we have here that our clocks each have their own piece of state, right? So if state wasn't individual, each clock would independently try to update the time, and so it would throw everything out of sync because there would be 3 components trying to touch the same piece of time, and things would just break. But instead, if in fact components are isolated and they can have their each independent state, we should be able to see from this app component that we actually will get 3 clocks that are each showing the proper time independently. And let's look at our CodePen example. And in fact, we see that that is the case. We have our 3 clocks, each independently showing the time. So even though we technically only have 1 clock component class and 1 formatted date functional component, we see that we have 3 different instances of it being displayed on our screen. And the state is just independent to each individual instance, and there's nothing weird going on with that. Okay, and then just one last little caveat down here. In React, whether a component is stateful or is an implementation detail, and in fact might change over time. And so it is totally kosher and Gucci to use stateful components inside of stateless components and vice versa, because the components don't really know that about each other. They just know that they're components and they can render each other. Okay, that's it for that video. Now you should have a better handle on state inside of React. See you in the next video.